Now, a motorcycle cartridge. Showed you one earlier. Here's a couple of examples. We have a piston rod and a cartridge body, and inside it we have a compression mechanism. We call it a base valve, right? And the rebound mechanism, let me show you, this one's crimped, I can't get it apart, is attached to the end of the rod, of the piston rod. This is the mechanism that controls rebound damping, all right? Now, a motorcycle fork cartridge is relatively crude compared to a modern shock. It's not a gas pressurized damping unit, and as a result, it gives a less consistent level of performance, okay? The motorcycle fork isn't run through any system that multiplies leverage on it, so it actually requires very little force. It's just a straight damping unit with no linkage, no complicated system around it. And then it's obviously divided into two. So the force and spring rate required in the fork are much, much, much less than what's on a shock absorber. Okay? So we have our body of the cartridge. We have a piston rod, rebound mechanism, and a compression mechanism. Okay? This will work much like a shock, whereas fork's going to compress. This area of shaft has entered the cartridge. Pressure is going to build up inside the cartridge, and the oil needs to go somewhere. Now, on the base valve, right, there is a one-way check valve, and then we have our valving that we talked about normally, right? Now, so when the fork is compressing, this one-way check valve is going to close, and oil is going to get forced through this valving, and it just flows out into the main chamber of the fork. Right? If this was our conventional fork, right, it's just going to get pushed out of this fork and out into the chamber of the fork. All right? The rebound mechanism, all right, its check plate is on top, and there's its valving. When this thing is compressing into the oil, this check plate opens, and oil just blows by it and does nothing. It should just be passing through the oil, okay? Now, when we stop and turn it around, and the fork's going to extend the other way, this check plate is going to close, and then oil, instead of going this way, it's going to get forced through the valving in this direction. And on the compression valve, since we're moving this up and we're getting an area of low pressure here, right? That check plate's going to lift up, and this oil is going to come back from the fork and refill the cartridge, okay? Now, it's important when you change the oil in your fork, if anybody ever does any of that, does their own routine service, that you bleed this cartridge, because remember, we're setting oil by level and not by volume, right? That you've bled this cartridge, and basically just by pulling up and down on it, you're going to suck, all the air will get pumped out into the fork, and then the level will, drop to wherever there's no air in it. And then we'll top it off to wherever the correct level is with a tool and check it, right? Now, the reason you can't set your fork by, in the old days, you'd get your ratio right out and the manual would say 400 cc's. Well, in a cartridge fork, you don't know how much oil you've gotten out of the cartridge. If it's got 30 or 40 cc's of oil left in it when you've turned the fork over and bled it, that's a lot of oil. It'll change the level dramatically, right? So the only way to do it is by level. That way you know that you're going to get the same performance each time. If you just take and dump your fork oil out and pump the cartridge a few times and then refill it by volume, you may end up with a level that's way higher than where it's supposed to be, and the fork will be very stiff and rigid and harsh over bumps. So not desirable, obviously, right? So when somebody comes in, the parts we're changing this piston, and we might be changing the shims that are on it, right? Depending on the configuration and design of it. Same thing here. Certain models of bikes, this is a ZX6R. We can take this apart. There's a nut we can take off. We can look at this piston. If we're happy with its design, we'll use it again. We'll change the shims on it, do what we want to do. Certain models of bikes like R1 and R6, it's a non-rebuildable component. We can't fix it. It's a little cheap stamped together piece of junk. We just unscrew it and throw it away and put a nice new racing assembly on it, right? So prices on having forks upgrade kind of vary depending on where you go. Some people that do shim changes and stuff will do it for as cheap as $300. If you're putting kits in, it'll get between $500 and $700 depending on if you have to have a compression kit installed and a rebound kit installed, right? And those upgrades will, include springs and somebody going through there, setting it up for your weight, aftermarket racing goodies installed, to make the fork work properly for track use, right? Now, you're on your motorcycle fork. You got an adjuster down here at the bottom. That screw is your compression damping. All right, up on the top of your fork at the fork cap, you'll have an adjuster. That's for your spring preload. The big main adjuster that you see, colored aluminum. In some instances, you'll see this bike has fingertip adjusters on it that you can just grab. They're a little aftermarket accessory you can just drop right on, so you don't need a tool. Moving that is going to change that initial pressure on the spring. The little screw in the center, that's going to be your rebound adjuster. Now, pretty much every adjuster everywhere on everything you're going to come across, when you turn it all the way in, that's 0. You've seated it, because what we're dealing with for the most part is needles and seats. Just like a mixture screw on a carburetor, right? We got a needle and a seat. So the only way to know where everybody gets to the same starting point and we're all talking about the same thing, screw it in until it touches, all right? Now, these are delicate, tiny little screws, right? Some of them, are not even steel, okay? Just turn it in until it touches, right? When it touches, it's not going to go any further. I mean, it will, but then you will have damaged it. So just turn it in until it stops moving. Light fingertip pressure, that's all you got to do. Once it touches, then we're going to count out, right? And so when somebody says I'm 5 clicks out on rebound, they're talking about they've turned that screw all the way in, backed it out 5 clicks. Now, clicks, to me, kind of like an idiot light on a dash. Some bikes have them, some bikes don't, right? One of the problems we run into is, if somebody wants to count their clicks and they've turned their screw in, there's a click there and a click there and it stops halfway between. What do you do, right? Well, the problem, first of all, most people will take the thing and keep turning it until it lands in a click, right? Which is, bad. And but then even if you're smart enough not to ram the screw into its seat, there's 0, right? We recommend that you just let it seat, back it out into the first click and call that 0, right? All right? And it isn't life and death that you get this right or wrong, okay? If you're one on one side and somebody else thinks it's 0, it's okay, right? No big deal, right? It's going to be relative when we go to tune, all right? So this adjuster, try and find 0, count out. Now it's great if you don't have it because you can just seat it and go in quarter turn increments. For the most part, quarter turn is noticeable for anybody on like these GSXR forks have no click to them. You just turn the screw, right? So no matter where the thing ends up, everybody knows where 0 is, and you can meter out in quarter turn increments, right? Let's see what else I can tell you. Your adjusters should move the same range on the top of the fork. If they don't, somebody's messed up the installation of the fork cap. It's a very, very simple thing to fix. If they're within a quarter turn or 1 click of each other, they're fine, don't worry about it. If they're 3 and 4 clicks apart, somebody's screwed it up, and what you're going to end up with is forks that are slightly different lengths, okay? So not horrible life and death situation, don't panic, but it's something that needs to be lined up, all right? When you install your forks, there's a couple of philosophies about how to do this. It's been theorized that the axle needs to pass freely through and spin by a fingertip on the fork. And what the theory is that they're not having uneven spring pressure on the forks, and that's in theory supposed to reduce stiction. Well, we don't even necessarily have to run identical spring rates in each fork. So that's just really not important. When you put the axle through, remember, the forks become one unit. And there's an experiment I did you can read about. It's at roadracingworld.com, or you can find it through a tech article on our website at Traxxion.com, where we tried crazy stuff. One giant heavy spring in one side, and found what worked and what failed, right? That one giant spring failed. but 2 slightly different spring rates didn't bother anything, right? Well, the problem with trying to make the forks line up to where the axle doesn't drag is that they'll end up different on top, right? They'll be, you know, 1/2 to 1.5 millimeters apart, and I've seen them as far as 2, right? Well, inside the cartridge here is a little top-out spring, right? This just makes it so when you accelerate and the wheel drops out from under the bike, it doesn't go clang. It's imperceptible to you. You never even knew it was there, right? But it is. Well, these things are pretty low tolerance parts, and if one of these springs is 1 millimeter different in length than the other, well, then the fork is going to hang at a different length, right? So what matters is not where the forks hang. It matters where they bottom out. And they need to bottom out together because they actually mechanically come metal to metal in the bottom of the fork, right? And if one gets there before the other, I think that's bad. So I suggest that whatever fork height one of your forks is at, the other one needs to be the same. That's my recommendation on installing your forks. That eliminates the confusion and fooling with the axle, and much faster as well. So don't worry about that thing spinning there. One I did forget to mention, by the way, along the lines of inspecting your tubes and having your forks leak, most common cause of fork leaks, rock nicks in the fork tubes. And it only takes a little tiny nick in your tube to tear your fork seal up. And what happens is, it isn't that when a rock hits it, it makes a dent, right? It actually makes a crater. Like, you know, when a meteor hits the earth, it's going to push metal up on either side, right? And now when your seal has to pass over those humps, the jagged hump from the rock, that's what's going to wipe out the lip of the fork seal. Now if you get hit by a rock, you know, and it's a noteworthy enough that you can scrape your fingernail across it, you can make one lap and have your fork leak, right? There's going to be, some of these things are beyond the world of suspensions control because we're dealing with a rubber part here. Fork seals are a wear item just like a clutch or a tire, right? So no way around it. You're going to run into these problems, right? So what I suggest you do is get a piece of 400 grit emery cloth and keep it in your spares kit. You know, take a look at the motorcycle once or twice a day and make sure you're not having, nothing's happened. Particularly if you're at tracks that are famous for sand or gravel on the track. Talladega, if you guys ride there, one of the most famous little tiny rock throwing tracks in the world. And what happens is, it's no problem when you ride, you know, you can ride a bike 25,000 miles on the street and never have this problem. But when you ride on a racetrack 5 feet behind somebody with a giant hot sticky tire that's flinging stuff all over your bike, that's where the problem comes, right? So following right behind somebody for, you know, a 30-minute practice session, you need to come in and look at your bike, right? And you'll notice on race bikes, you always see the fairing peppered, and you'll see the sides of the fender are all peppered, and the fork legs will be peppered, look like somebody sandblasted them. That's why fork protection is important, right? On these inverted forks, you get it with the fender usually. On conventional forks, you'll see the little black plastic guards sticking up. Those things are important, and you want to make sure if they get broken or cracked off, you get them replaced because it's the cheapest money in the world. 25 bucks for a pair of fork guards compared to $150 to have your seals changed. No comparison there. So polish that thing, and when you polish it like you're shining a shoe. And it'll leave, you know, fine coarse scratches in it, and that actually, those fine coarse scratches actually help reduce stiction. Much like if you ever seen somebody build a motor when they run a hone through a cylinder, and they leave a crosshatch, that holds oil, and that actually helps reduce stiction. So it's one of the things we do to reduce stiction in a fork. So second thing to keep an eye for, bugs. You go to a track with a lot of bugs around here. You go to Savannah, you know, particularly where you can practically walk through the bugs, you know, in the paddock. If you've got stuff splatting on your fork tubes, one quick splat of a bug and they dry up hard, and you pumping that thing up and down and run a 12-lap race, that bug will wreck the fork seal. So scrape the bugs off. You know, keep something around to clean and wipe your stuff up in a quick eye. You know, every time you ride your bike, it can save you a lot of money. So that's the word on fork seals. Bent and twisted front ends, that'll make fork seals leak. Hopefully your bike's not bent or twisted and you're trying to ride it around the track. I have seen that before. Let me think if there's anything else I want to say about forks. Any questions about forks? All right.